All attendees are in listen-only mode.
Welcome everyone. My name is Tracy Fitzpatrick and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We're excited to host today's technical webinar, a deep dive in the world of IT networking. And presenting today's topic is Magdi Silfen. Magdi is a chief engineer, information technology professional, and a network security consultant with 20 years of experience in IT operations and 14 years as an IT technical trainer and learning consultant. Now, please bear in mind that this is an overview of a very robust topic. We offer a collection of technical and business courses that can be tailored towards your specific requirements. Now, if you are interested in further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. Netcom Learning is an award-winning global leader in managed learning services, training, and talent development. We offer over 2,000 plus IT, business, and soft skill courses available to organizations around the world, encompassing all your technology and business needs. Netcom Learning is the most trusted name in both business and IT training and offers top-notch instructors and vendor-approved coursework, offering certification preparation for a variety of vendor certifications. So, why should you attend this webinar? For a successful career in information technology, a strong foundation of basic networking concepts is a must. Networking technology allows for the exchange of data between large and small information systems used primarily by various businesses. And now I'll just give you a quick overview of the logistics before we get started. To start with, you do have the option to adjust the window size to your liking. Simply hit the escape key and find the zoom button on the top left corner of your GoToWebinar viewer. Everyone has been muted except for our presenters. Please feel free to submit any questions that you have for the presenter here in the questions pane, and we will address them at the end of the session. A PDF copy of today's slides are also in the handout section of your GoToWebinar viewer. And now I'm going to pass it over to Magdi, who will be presenting today's topic. Magdi, go ahead.
Thank you, Tracy. Today is the second session of the deep dive in the IT networking world. And today's agenda is the OSI model, TCP or D.O.D model, networking protocols, networking and data security, and then we are going to be having some time for questions and answers. We are going to start by the OSI model, and the OSI here is written all in capital. It's different than any other Cisco or iOS from Apple. Those are products from other companies. The OSI model is a logical representation of the network operations. We call it the Open Systems Interconnections. It's a reference model between every single IT professional and developer worldwide for understanding what's going on the network. For any developer who wants to develop an app or develop a program that work through the network, through our networks, they have to have some deep understanding about that. For any IT professional or network administrator, they have to have deep understanding for their own backbone, which is a network. The OSI model is enable this knowledge to the other people that work is in the IT career. It's divided into layers. Those layers are representing the data traveling through the network. So how we are presenting that 7 layers, we usually go from the transmitter to the receiver, while the data travels into those layers until they are traveling through the physical link or the physical network and again to the receiver. So we have two users here, and both of the users, one of them is sending data while the other one is receiving data, and look at that as like an email. Someone is composing an email and sending to another person. So we are having the application layer, then the presentation layer, session layer, transport layer, network layer, data link layer, and finally the physical layer. Through that, we are presenting 7 layers, starting from the application to the physical, and the physical layer usually is the first layer, and the application we call it the 7th layer. And usually we are putting those layers in some easy to remember sentence. So we are going to be presenting that descending from the 7th layer to the first layer as all people seem to need data processing. That's again descending from the 7th layer, which is the application layer, to the first layer, which is the physical layer. And if we want to reverse that, and apologies to the sales guys around, we will be saying, please do not trust sales person always. So from the first layer to the last layer or the 7th layer. So what are the functions of each layer? What are the keywords? What are the protocols that working in each layer? And bear in mind, those protocols may be working across layers. So that you find a protocol that work in a layer like layer 7, which is the application, and then you find it works in some other layers as well. So we are going to go through each layer in details. First layer is the application layer. The application layer is described as the user interface layer. And think about it as your web browser or your email client, like Outlook or Thunderbird from Mozilla. It's something that you write your email in and compose it, and it has a user interface. That's where the blank area that you write your email in. The protocols that are working in this layer, those are samples, but not limited to those protocols. We have the SMTP, the SNMP, the FTP, Telnet of course, and HTTP. Moving to the presentation layer, which deals with the binary and character set translation. The presentation layer is responsible for data format, encryption, and exchange of the data. The protocols that you can find in those are the file formats. And of course, for those who don't know the file formats, we have lots of file formats, and as example, you can find the MIDI and the WAV for the multimedia. You can find the MPG, WMV, AIV for the video. You can find the JPG, the TIF for the images. You can find the TXT and docx for text. Moving to the session layer, it's responsible for establishing and maintaining sessions, the communication sessions between the two users or a user and a web server, for example. And that the session layer is responsible for setting up, maintaining, and terminating communication sessions. Samples for the protocols that working on those in this layer specifically, we have ASP, NFS, RPC, and X Windows from Apple. Moving forward to the transport layer. The transport layer is responsible to establishing reliable end-to-end data delivery. And you can find that through sending an email. And if your email is not delivered to the other end, or for the person who's supposed to be receiving it, you get a notification from the mail server that telling you your message, your email couldn't be sent or couldn't be received. We call that type of connection a connection-oriented. And same with the file transfer. When you transfer files between hard disk drives, for example, or your flash stick and your computer, and if you are copying these files from one to another, one location to another, and if the copying process didn't complete successfully, the computer system will show you a message telling you this device or this data or this copying process couldn't be finished successfully. So that's what we call connection-oriented. For the protocols that they are working across this layer, we have the TCP protocol, we have the SPX protocol. Then we will come to the network layer. The network layer is responsible for the addressing and routing, and responsible for the IP, and all of us, of course, who are working or at least have a computer, so they know that they are getting an address to access the network. So we have the logical addresses, which is the IP address. We have the path determination in this layer, and we have the routing. The protocols that work across this layer is the IP, IPX by Novell, Apple Talk by Mac or Apple. And of course, if you ever wondered what physical device that we are using in this layer, the most recognized physical device we are using in each day life when we connect to this layer is a router. So each one has a router in their homes. That is the physical representation of the network layer. Then we will have the data link layer. The data link layer is responsible for converting bytes and bytes to frames. So it converts first bits to bytes and bytes into frames. MAC address or physical address usually is represented in this layer as well. The protocols that they are working in this layer are LAN protocols, 802.2 logical link layer or logical link control LLC, 802.3 which is Ethernet, 802.5 which is a token ring, and of course the very famous protocol that everyone uses everywhere, worldwide, every day, it's 802.11, which is our wireless protocol. That's for the LAN protocol. For the WAN protocol, we have the data link layer or the high-level data link control protocol, which we call HDLC. And we are having the TCPIP or PPP point-to-point protocol. The physical representation from the network device world, we have the switches, the bridges, and the network interface cards. Finally, we will come to layer 1, which is a physical layer. It's responsible for placing data on the network in the forms of electric signals. And the electric signals, it's like on-off switch, and on equal to 1, that's mathematical representation, and off is equal to 0, which is a mathematical representation as well. And that's how the data travels over the network in those forms, zeros and ones. The physical representation of this layer will be the cable and the connectors. And of course, now we are having wireless, so any network medium that is used in data transfer between network is going to be presented in this layer. After this summary for the OSI model, we have the advantage of the OSI model. Let's get into that. It provides language preferences between network professionals. So starting from a help desk person to an enterprise administrator, which is the enterprise level of network management. Everyone across this line needs to know by the heart and by the mind how the OSI model work in the real life and what it represents. That's your language. I talked about the language skills in the previous session of this webinar in part 1, and this is your language. For any IT professional, any developer, they need to know that language. It divides the network tasks into logical layers for easier comprehension. And of course, if you want to understand what's going on through the network, to troubleshoot the network or to design an app or to engineer a program, you will have to know what's going on. Those layers, the OSI layers, help you for the logical understanding of those layers and for your program or for troubleshoot to be successful and work. It's allowing specialization of features at different levels. So I'm going to give you an example. For a systems administrator who is responsible to run a network operations, he or she needs to understand what's going on, and when they are designing a deployment of a project, and their role is to manage through those layers what's going on. But for a junior network professional who is responsible for cabling and deploying devices, so they know exactly which layer they are working for and deploying those devices in. It aids in troubleshooting, and of course we have commands from our computers to run those commands and to run the troubleshooting. That's logically, and if we are going to be running that physically, and we are going to be tracing the signals through the network through our network testers, that's through the physical layer. And of course, it is to standardize the connections between devices. So we know when the data is traveling from a sender to a receiver, how it's going to be traveling from logical layer to another logical layer, and what's between those layers. We have some disadvantage of this model, and I call them limitations, not disadvantage. The OSI layer is a theoretical representation. In the real life, we will understand how the data, that's how our minds will understand, but we actually don't have a layer by layer connection in the real life. Maybe some protocols, as I indicated before, will work across layers. They are not going to be bonded to only one layer. At some particular protocols, it might be implemented in one layer, but will not be expanding to some other layer. We have another representation for the data traveling from a sender to a receiver. This representation, we call it the TCPIP model. It's a model invented by the American Department of Defense. The stacks of the OSI model are compressed into 4 stacks instead of 7. The first layer, we call it the data link layer, or simply known as the link. And also in the real world of the IT professional, we call it the link layer or the network layer. Then we have the network layer, which also known as the internet layer. That's where the data is going to be traveling outside your LAN. Then we have the transport layer, which contains the transport and the network layer of the OSI model. Then we will have the application layer, which is representing the session and presentation and application layer in the OSI model. So what are the network protocols that I talked about when I was presenting the 7 layers of the OSI model? Before we start that, I would like to have a quick touch on the connection-oriented and the connectionless protocols. The connection-oriented, or the CO, is a session initiation, error detection, and error correction protocol. It identifies the lost packets and the lost messages, and if the message is not received, it will be asking the sender to send those messages again. And I gave an example when you are sending an email and your email couldn't be delivered or couldn't be sent, and the message will appear in your inbox as a feedback from the server telling you, please, this message couldn't be received or sent, please send it again. That's a connection-oriented protocol. While the connection or connectionless protocol, which we are referring to as the CL protocols, it's assuming there is an existing link between the devices, and will be working on sending the data regardless, checking if the data are received or not. I'm going to give an example here. When you are streaming a video from the YouTube web server, sometimes when your connection is very good, up and running, you will have the video quality is very good, it's not stopping in the middle, nothing is happening, it's playing smoothly. When you don't have a reliable connection, sometimes you will find your video stopping and then continue at some other spot. So it doesn't matter if the data is received in a proper manner. The connection is oriented less. It doesn't check if your data was received correctly. The connection-oriented protocols usually have larger header and more overhead over the network, while the connectionless, because of not checking your data, it has smaller header and less overhead. The connection-oriented protocol will provide data acknowledgement. So when you receive the data, you probably going to be, those data are checked and sent and received in a proper manner. It has the data flow control and error detection. So if any data is not receiving during that connection-oriented protocol and through those layers, it will be acknowledged and will be prompted to be sent again. While the connectionless doesn't provide any additional service, but only sending the data and don't care about if it's received correctly or not. The connection-oriented protocols has the acknowledged transmitted package, and that consider high reliability control. And that's one of the things, if you need another example, when you are downloading a file from the internet and your download agent, whether it's a web browser or a download manager, is downloading this file for you to your computer, you will find the data is transmitting, and once it is finally transmitted successfully, you will find a message appear to you that's saying your file has been downloaded successfully. For the connectionless protocols, they don't have the acknowledgement of the transmitted data, and they don't consider having high reliability protocols. We are going to be discussing some of those protocols in details right now. And the very first protocol that I would like to discuss with you today is a transmission control protocol, which is a TCPIP. The OSI layer that represents this protocol is a transport layer. The Department of Defense model layer will be the host-to-host, edge-to-edge layer, which is we call the transport. It provides connection-oriented service. It's responsible for the sequencing and the addressing of your data. It provides error checking and consider as reliable protocol. The UDP, or User Datagram Protocol, it presents in the transport layer, and that's in the OSI model. Also, it will be represented in the host-to-host transport layer in the D.O.D model. It performs functions like video streaming, audio streaming over the internet. It considers connectionless protocol. Unlike the TCP, it doesn't have that overhead on the network. It is faster than the TCP protocol, but not having high reliability. We talked about the file transfer from the internet and downloading file to your computer, or uploading file to your web server, or hosting your website. That's what we are using. We are using File Transfer Protocol. The OSI model layer for that is going to be actually 3 layers, so they are going to be application, presentation, and session. The Department of Defense model layer is going to be application and / process. So it is the 7th layer. It is a very generic method to transfer files. And I gave an example. Either you are transferring files to your web server, so you are uploading your web server or your website to the internet. You are downloading file from a server over the internet. That protocol is governing the file transfer between computer systems. Then we are having the most famous and most usually on every single second in our life, when we are having a handheld device or a phone and we are browsing the internet, we are having the great hypertext transfer protocol, the HTTP. The OSI model is the application and presentation and session layers. Those are the layers that they're presenting, or this protocol is traveling across. The Department of Defense model, or the TCPIP model, is going to be the application or the process. And think about that. You open your browser over your phone, your tablet, or PC. You type www.netcomlearning.com. And then when you hit enter, you will find the web browser put http://www.netcomlearning.com. By itself, the internet browser knows that it should be presenting before the World Wide Web address, which is netcomlearning.com. So that's how the OSI Model, or the Department of Defense Model, is presenting this in real life. We are having also, and that for any IT professional needs to know, the simple network management protocol, SMMP. The OSI layer for this protocol will be application, presentation, session. The Department of Defense model will be application/process, which is the 7th layer in the OSI model. It is for controlling the devices and the configuration and exchange those configuration between hosts. And by the word hosts, we mean any device connected to our network, starting from your handheld device, which is your phone, tablet, or laptop, and ending to the server. And in between, you will having router switches and whatever any devices between them. That's how this protocol is working between those layers. The information is gathered by the management software, usually on the network. Usually that can be using to monitor the network. And those who are in Cisco, we have our software to do that, while in Microsoft we have the System Center and Microsoft Endpoint Protection, and in IPM we have other applications and programs that do that. So we're having a wide varieties from the network controlling software that can gather the information from this protocol and can confirm those packets and those applications are working fine when exchanging data. We have the simple mail transfer protocol, SMTP. And for those who ever set up an email agent like Microsoft Outlook or Thunderbird from Mozilla, they will know, they will be asked on prompt when they are setting up their email if they want their email to be going through the simple mail transfer protocol, the SMTP. Its main function is to route the emails between a sender and receivers. It works in the OSI model through 3 layers: application, presentation, and session. While it works in the D.O.D model or the TCPIP model as application and process layer. One of the most famous protocols is the DNS, and we call that the domain name systems. Those who don't know the domain name systems and would like to work in the IT field, this is your best friend when you are a network administrator. What this protocol do? Simple, it transfer your address, your web address, www.netcomlearning, for example, .com, into an IP address of the server that hosts this www.netcomlearning.com page. The OSI model is the transport. The TCPIP model is the host-to-host or the transport layer. Finally, and I don't think that's going to be finally, we have lots of protocols. the DHCP, or the Dynamic Host Configuration Protocol. The OSI layer is a network. The TCP/IP, or the D.O.D model, is going to be the internet. It is responsible for delivering IP configuration to every single machine or every single host over the network. It's specifying how the IP address is assigned and for how long this IP is assigned for a particular host. The Internet Protocol, IP. The main TCP/IP protocol that is work in the OSI Model layer network and also implemented in the D.O.D model layer in the internet layer. The TCP/IP is a connectionless protocol, but it makes the routing path decisions based on the information from another protocol called ARP. It handles logical addressing issues, and you can all the time know the configuration from your PC through the command line through ipconfig/all, and I gave a representation for that last time in the first part of this webinar. Transferring and talking to some other areas, which is the network and security. In order to transfer your data over the network, you have to make sure that those data are secure. In order to do that, we are having a very, very famous connection called the Virtual Private Network, VPN. The VPN usually is a connection between two devices through the internet, through your ISP or Internet Service Provider. While the VPN client will be sending a request to the VPN server and then receive a response in a virtual private network secured path, while those data are not shared with any other devices connected to the ISP. Those client and server are not in the same network. In order for the data to be transferred through the ISP network or the Internet Service Provider, they have to go through two processes: the encapsulation process and the encryption process. A tunnel between the two devices is created through the LAN and the WAN connections. So from router to router and from device to device, there is an imaginary tunnel here that established connection between the computer and the server for those data to be transferred. To do that and to secure also the data, you always gonna be using a firewall, either on your PC or your network, your PC at home, your work network. What is the security devices here? The security device is a firewall, which is responsible to protect all the devices in your LAN that behind this firewall from the internet attacks. Security devices as firewall are presented heavily in today's IT world. They are the most common type of security for any organization. While the perimeter security zones, or also we call them the militarized zones, the DMZs, help to keep some certain devices away from the attack, but also have their own protection and their own connection for the user to connect to. A network intrusion detection system. NIDS, that's how we are referred to this type of connections. The network intrusion detection system is a type of preventing attack to the network, such as port scans or DOS attack. The NIDS will see those attacks. It will report those attacks and issues to the network administrator. Then a network intrusion prevention system, it will work online to prevent those attacks based on its configuration and security policy. So the network administrator will previously configure this device and let it learn the roles and how it's going to be defending the network. So it can remove any attacks or any scans, any traffics that are not allowed to the network, it will be stopped. The DMZ, as I was talking about your network and how your network is protected by a firewall, it's like, think about it like a military zone. And that military zone is not allowed for any other people or any other personnel out of that zone to enter that. But sometimes when we work from home and we need to enter to that zone, the network administrator or the IT administrator or the security administrator will not be allowing this. Instead, they will give us some server that on the extranet that they are not protected by the firewall out from the firewall of the company. And we call that the DMZ. The DMZ is some servers that you are allowed to connect to, and through them you can get into your work and you can work from home, or if you are in a vacation and you want to do that, you are allowed to. The other name of the network in that configuration is called the perimeter network. When you are working from home, and that's ideally what the people think, they think they are usually work on their own computers and their own servers. The exact and the ideal connection is those servers are requiring connection to the internal network and get the user data and host it into them and let the other those users access these data. That's why we call it the demilitarized zones. By this, I end the second part of this webinar. As a reminder, this webinar is considered a session in the Netcom IT Academy program. So when you are enlisted in our courses, you don't know anything about the IT, you start from scratch and you will learn about how to build a computer until the expert level. You will be going to the expert level either through Cisco or Microsoft or CompTIA curriculums. Stacy?
Thank you so much, Maggie. That was very informative, and we want to remind our attendees that we do have a special promotion for the Caroline. She wants to know, what are DMZ configurations?
Oh, the DMZ configurations usually have two main configurations. One of them called the back-to-back configuration. Let me get to that slide. And the back-to-back is a configuration that has the DMZ situated between two firewalls devices, which could be block box application or a Cisco device, for example, or Microsoft Internet Security application, or ISA server, that's another application. And that back-to-back configuration is where you configure that DMZ to be protected from the outer attacks and also preventing that data from the DMZ to travel, the unauthorized data from the DMZ to travel to the internal LAN of the company. Also, we have a very famous configuration. It's called the three legs perimeter configuration. In that scenario, the DMZ is usually attached to a separate connection of the company firewall. Therefore, the firewall has three connections to them. One to the company, LAN, one to the DMZ, and then the third one to the internet. So those are the two most common DMZ configurations.
Okay, we have another question from Tom. What are the VPN protocols?
Okay, the VPN protocols, and let me get to that slide very. Okay, the VPN protocol is usually having two main popular protocols. One of them is P2P, which is point-to-point tunneling protocol, PPTP. It's most commonly used to control the data and the tunneling between two devices. It's also less secure option. PPTP is including security mechanism and maybe has functions of the additional software or protocols be loaded in order to apply that protocol. A VPN device or a server that allows a PPTP connection must have inbound port 1723 open. PPTP works within point point-to-point protocol, which is PPP, that also used a dial-up connection. While we are having level 2 or layer 2 tunneling protocol, which is L2TP, it's very popular right now. It's implemented through the security protocol IPsec. Although it is a separate protocol from the L2TP, which doesn't have any inherited security. Layer 2 tunneling protocol considers the most secured connection and solution based on the IP security, which is required by the most LTTP implementation. In order for it to work, port number 1701 has to be open in your firewall. That's it.
Okay, any other final thoughts before we end today's session, Maggie?
Keep up and mark your calendar for Windows Server Foundation Administration. Those are going to be another two webinars in this series from Netcom IT Academy. And keep an eye through June and mark your calendar. Please check netcomlearning.com/webinars and mark your calendar. I'm going to be presenting 2 sessions for server administration and the basic of Windows Server administrations next month in June.
Okay, great. Thank you, Maggie, and thank you all for joining us today. And if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.